Hey everybody, time for Chapter 1, Section 4. Title is Properties of Real Numbers. Starts on page 23. A couple of definitions. Relationships that are always true for real numbers are called properties. Those are rules which are used to rewrite and compare expressions so you can do things with them. These are true for all real numbers. Two expressions are called equivalent if they have the same value no matter what you plug in for the variables. You can see that in the word equivalent, that starts kind of like the word equal. You're going to see why that is in a little bit. We're going to talk about 5 properties of real numbers. The first one is called the commutative property. It changes the order of the items, so you're switching things around. These are items that are going to be added or multiplied, so there's 2 different kinds of commutative property. The commutative property of addition, it's an addition problem, and what I do is I take the numbers and I switch the numbers around. So instead of 18 plus 54, I can do 54 plus 18. Those are equivalent because if I solve each side of that equal sign, I still get the same answer. There's also the commutative property of multiplication. It's a multiplication problem, and the order of the numbers changes. So instead of 3 times 4, I can have 4 times 3. The stuff on the left gives me 12, the stuff on the right gives me 12. Doesn't matter which order I put those in, I still get the same answer. The second property is the associative property. This changes where the grouping symbols are, changes the placement of the grouping symbols. If you're moving the grouping symbols around, then it's the associative property. There is an associative property for addition. So you see the numbers stay in the same order. On the left, we have 23, 9, and 4. On the right, we have 23, 9, and 4. The only thing that changed is where the grouping symbols are. If I solved both sides of that, I'd get the same thing both times. There's also the associative property of multiplication. I have 7 and 9 and 10. On the right side, I have 7 and 9 and 10, so the order stayed the same. The only thing that changed is where I put those parentheses. Okay? If I solve both sides of it, I'll get the same answer. 7 times 9 is 63. 63 times 10 is 630, and I get the same thing on the right side also. The next property is called the identity property. If you think about the word identity, identity is who you are. Okay? You can't change who you are. In the identity property, the value of the original number does not change. It stays the same. So there's an identity property for addition. If I start with a 5, what do I have to do with a 5 so it doesn't change? The only thing I can do with a 5 so it doesn't change and stays the same value is add 0. So another way of thinking about the identity property of addition is just add 0. If I think about multiplication, what do I have to do in multiplication so that the number I start with doesn't change? Well, if I start with a 3, in order to get an answer of 3, I have to multiply by 1. So the identity property of multiplication is the same thing as multiplying by 1. The number that I end with is the same as the number that I started with. That's what the identity property tells us. The next property is the zero property of multiplication. Anytime I multiply by 0, my answer is 0. 4 times 0 equals 0. Doesn't matter what this number is. If I multiply by 0, my answer is always 0. That's called the zero property of multiplication. There's also the multiplication property of -1, which means if I multiply anything by a -1, what I'm really doing is I'm changing the sign of the number. So if I start with 9 and I multiply it by -1, I get -9. Multiplying by -1 just changes the sign. Let's look at how to actually use these properties. Example 1. Which property is illustrated by each of these statements? So, in part A, 4x times 1 equals 4x. Well, I start and I end with the same thing, and I multiplied by 1, So that is my identity property of multiplication. I started with 4x, I ended with 4x, and it's a multiplication problem. So identity of multiplication. Letter B, x plus parentheses, the square root of y plus z parentheses. And then over on the other side, x plus parentheses z plus square root of y parentheses. There's parentheses in this problem, but did the parentheses move? No, they didn't. Associative property is the one where the parentheses moved. Commutative property says that the order of my things changed. Well, I've got x, y, and z in this one, and over here I've got x and then z and then y. So on the right side, the z and the y switched places. I changed the order of my objects, so that tells me it's the commutative property. And see, since it's an addition problem, it's the commutative property of addition. You can use these problems to help make these properties to help make math problems easier. These are going to be called mental math problems, but you do have to show your steps. Just because it says mental math doesn't mean you can do it all in your head and that you don't have to show any work. In fact, I do need to see this work to make sure that you're doing them in the correct way. The whole key here is to use the properties to put numbers together that are easy to work with. You're trying to make nice, whole, easy to work with numbers. Here's an example of one of these. Example 2. Simplify 2 times 7 times 5 using mental math. Now, if we just think about this for a second, these are not big numbers. I could probably do it. So I would do 2, using the order of operations, I would do 2 times 7, that's 14, 14 times 5. You know what, that's not one of the things that I necessarily remember off the top of my head. So let's see if there's an easier way to do this. There's my original problem, 2 times 7 times 5. Okay? I don't want to do 2 times 7 is 14 and then 14 times 5 is something because I can't think of it. But what I can do is there's 2 numbers in there that are really easy to work with. I know 2 times 5. 2 times 5 is 10. 10's a number that's really easy to work with. But what I did here is I switched the order of the numbers. Instead of 2 times 7 times 5, now I have 2 times 5 times 7. And I switched those 2 numbers around. When I switch the order of the numbers, that's the commutative property. This is a multiplication problem, so it's commutative property of multiplication. Now, the reason why I did that is because 2 times 5 is 10, and it's really easy to do 10 times 7. It's really easy to do 10 times anything. 10 times 7, I multiplied in order to get from there to there, and then I multiplied again to get my answer. Okay? I did one step of work for each line, and I just kept going until I was finished. The words shown over here on the right, those are called justifying. It means you write down the reason why you're allowed to do each step. The top line was the original problem. Then in order to go from that line to the next one, I used the commutative property of multiplication. Then from there to the next line, I multiplied, and from there to the next line, I multiplied. Every time I do a step of work, I have to give a reason why. That's called justifying. Another example. Simplify 2.1 times 4.5x. Okay? The parentheses would be telling me that I need to multiply 4.5 times x, but I can't. The 2 things that I can multiply are the 2.1 and the 4.5. So that's my original problem. I can multiply the 2.1 and the 4.5, so I put those in parentheses. All I did is I took the parentheses and I slid them over. I moved where my parentheses are, so that is the associative property. Then I multiply, and I get 9.45x. In the next example, I'm trying to simplify 6 plus and then 4h plus 3 in parentheses. Now I can't do 4h plus 3, I can't add those together, but I can add the 6 and the 3. So I need to try to get those to be next to each other. I changed the order of the numbers, I switched the 6 and the 4h, And when I change the order, that's called commutative property. Now, since they're together, I can add the 6 and the 3. 4h plus 9 is my answer, and the reason why I could go from this step to that step is because of addition. One more example of these. Simplify 8m over 12mn. Okay? We'll break this up into two pieces, one for the numbers, one for the letters. So, I'm going to do 8 over 12, and then I also have m over mn. Okay? 8 over 12, I can simplify that fraction. I can take a 4 out of both of those, and 8 over 12 turns into 2/3. If I have the same thing on the top and bottom of a fraction, it can cancel. So that m can cancel out with that m, and all I'm left is with this n here. But that n is on the bottom of my fraction, so in my final answer I have to put it on the bottom of my fraction. So I simplified the numbers, I canceled out something that was the same on top and bottom, and I put the piece that was left over where it goes. Last topic here. A counterexample is something that shows that a statement is false. So we're going to use that in a problem. This problem tells us, these are the directions, use properties to show that the statement is true, or use a counterexample to show that it's false. And we'll do one of each of those. Letter A, we're supposed to find out if what's put there is true or if it's false. So I'm going to try to use properties to rewrite this. Okay? So I'm going to leave the first part alone, and I'm going to try to change the second part so it ends up looking like the first part. So can I turn the right side so it looks like the left side? First thing I can do, I can use the commutative property of multiplication to change the order of things. Okay? So I move the t, the s, and the r around, and I get r times s times t. It still doesn't exactly match what I've got on the left-hand side, but I can use the property, the associative property, to move my parentheses. Now, the thing on the right looks exactly like the thing that I started with, so that proves that it is true. Another example, x plus 0 equals 0. I don't recognize that as a property. So I'm going to see if I can come up with a counterexample to show that that's false. Can I plug in a number where that x is, where this isn't true? Sure I can. If I plug in a 3, is 3 plus 0 equal to 0? No, it's not. 3 plus 0 is equal to 3. So 3 and 0 are not the same thing. So that would be false. Okay? You can either use properties to show that something is true, or you can use a counterexample to show that something is false. Your practice problems for this lesson, page 26 and 27, numbers 7 through 45.